Here we're looking at a rain cloud that contains a lot of water vapor, but clouds are pretty big, and if they're nice, heavy, ready to pour rain clouds, they should have a whole lot of water vapor inside. We want to see how long it should take a 2 kilowatt pump to raise the same amount of water to the cloud's altitude of 2 kilometers. Okay, so let's look at this. It's got a rain cloud that has that much water vapor, so I've got a mass of 2.66 times 10 to the 7th kilograms. It's pretty heavy. Okay. We want to see, we've got a power output of 2 kilowatts, which is 2,000 watts. Okay. We want to raise it to the same altitude of 2 kilometers. So that should be our displacement. Okay, we need that in meters, so that's 2,000 meters. Okay, we're looking for time. So again, we've got power is equal to work divided by time. We can redefine work as force times distance. We can redefine force as mass times acceleration. Okay, so this is probably going to be the best bet in this case because I do have a mass and a displacement. If we're working vertically, remember we're going to use the magnitude for g. Okay, so I'm going to say power is mass times acceleration times displacement. And in this case, acceleration is going to be g divided by time. If I'm looking for time, I'm going to go ahead and swap those guys out. So what time is mass times gravity times displacement over power. So it's going to be 2.66 times 10 to the 7th kilograms. I don't have enough room. Times 9.81 meters per second squared times 2,000 meters. All over 2,000 watts. Okay, you could see that 2,000 divided by 2,000 is going to go away, but let's just go ahead and plug everything in case those numbers were not the same. You can get the same algebraic process here. Okay, time is going to end up being kilogram meters per second squared times meters. That is still a joule. All right, let's plug this in. So we got 2.66 times 10 to the 7th times 9.81 times 2,000. All right, and we get 5.22 times 10 to the 11th joules divided by 2,000 watts. Okay, so we're going to take that and divide it by 2,000. All right, and we should get joules divided by watts will give us seconds. And we should get 2.61 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Okay, so a lot of seconds, but a lot of us don't really have a good grasp on how many seconds there are in different intervals of time. So I'm going to go ahead and change that to hours. So we got 2.61 times 10 to the 8th seconds, and I know that there are 60 seconds in 1 minute, and there are 60 minutes in an hour. Okay, then I'm going to take that number and divide it by 3,600. That's 72,485 hours. Still doesn't seem so much. Let's get another paper. Actually, we're going to just bring this up here so that these are both acceptable answers, but let's put it in terms that are easy to understand still, like further. Because we can talk about 72,500 hours, and that doesn't really let us grasp the order of magnitude that is. Okay, so 7, 2, 4, 8, 5 hours. Okay, see how many hours are in a day. We got 24 hours in one day. Taking this number divided by 24 is probably not going to be a lot, so let's go ahead and turn days into years. We've got 365 days in 1 year. So hours cancel, days cancel. We're left with years. So let's take the amount of hours, turn it into days, And then turn that into years. And we still have over 8 years. Okay, so this number is a lot of seconds, but it doesn't seem so big until you convert it into a more reasonable and easy to deal with time frame. Okay, it's a lot of time. I'll accept any of those answers.